I'm a vegan, which obviously, as everyone knows, means I eat a lot of grass. It makes up the bottom 3 rungs of my food pyramid. The top one is reserved for summer rolls with peanut sauce, of course. But despite me pleading with the vegan gods, my stomach is just not built to digest that much grass. But you know whose is? Freaking cows. They eat grass all day. Every day. If I was anyone else, I think that's boring as hell, but I'm a vegan, so I get it. Hidden inside that gentle giant munching away in some pasture somewhere is one of nature's greatest engineering marvels, a stomach that can turn something as simple as grass and hay into energy. It's not just any stomach, it's a 4-chambered microbial factory that is so effective that scientists and engineers decided to copy it. Welcome to part 2 of my 3-part series on how humans use animals in the name of beauty, innovation, and progress. In part 1, we explored how artists like Antoni Gaudí and Damien Hirst blurred admiration and harm using animals as aesthetic tools rather than living beings. Today we're jumping from art galleries to science labs and industrial sites to talk about biomimicry, copying nature not for its style but for its functionality. Like Velcro inspired by birds clinging to a dog's fur, or bullet trains redesigned after the beak of a kingfisher to stop sonic booms, or wind turbine blades borrowing their curves from humpback whale flippers, or termite mounds teaching us how to build buildings that cool themselves without air conditioning. We'll see how major technologies, some of them groundbreaking, have been inspired by animals that we routinely exploit. But let's start with the sexiest topic of them all, cow stomachs. Organic waste management might not sound exciting, but it's one of those global crises we need a solution for like yesterday. We're tackling overflowing landfills, methane emissions, piles of food waste, not exactly humanity's proudest achievements. All sorts of technologies have been dreamed up to address these issues. Among them, the anaerobic digester, the technology inspired by none other than the humble cow's stomach.
A former 9-acre dumping site on the south side is now home to a uniquely engineered machine that's helping feed and heat Chicago in a clean and sustainable way. An anaerobic digester breaks down organic matter without the use of oxygen. There are thousands of them across the country, but none quite like this one. Trucks are driving in daily, carrying hundreds of tons of food waste, some still in its packaging. It all gets dumped into a giant pit.
A cow's digestion is a masterclass in efficiency. Their 4 chambers, made up of the rumen, the reticulum, the omasum, and the abomasum, break down tough plant fibers in stages. The largest chamber, the rumen, hosts a bustling metropolis of microbes, bacteria, protozoa, fungi, archaea, each specialized in converting cellulose into usable energy without oxygen. Inspired by this process, anaerobic digesters replicate the cow's gut on an industrial scale. Organic waste enters sealed tanks and undergoes a multi-stage microbial breakdown. In the first metaphorical chamber, large molecules are simplified, then these simpler molecules become fatty acids, the fatty acids transform into acetate and hydrogen, and then finally the microbes convert acetate into biogas, primarily methane and CO2. The engineer explains,
"This is the mouth that's sort of chewing up, spitting out the packaging, and then swallowing that liquid food waste that kind of goes through sort of the intestines or the piping into the digester." It's almost exactly what's going on in the cow's stomach that we're replicating here.
Facilities like Energia in California divert thousands of tons of food waste annually from landfills, significantly reducing methane emissions and producing renewable energy. This biogas can generate electricity, heat, or even power vehicles, and the leftover slurry provides rich fertilizer. Here's where I have to hit you with some massive irony. A huge portion of what these digesters handle is animal waste, specifically meat, and beef being among them, cow meat. According to USDA estimates from 2010, 26% of meat, poultry, and fish produced in the US never even makes it onto a plate. That's about 1 billion chickens, over 100 million pigs, turkeys, cows, and approximately 40 billion aquatic animals discarded every year. That means we're raising billions of animals whose bodies just end up in landfills. So we study the cow's body, we marvel at its digestion, we build technologies that mimic it, and then we toss countless cow corpses right back into the system that is inspired by the animal we discarded. Ouch. Cows are obviously not the only animals whose biology we've borrowed from. If you're anything like me, you're subscribed to Boston Dynamics and flinch every time a new video hits your subscription notifications. You know robo animals are a thing, sometimes really freaking cool, sometimes solidly within Uncanny Valley. But what I think is some of the coolest biomimicry technology is the kind inspired by octopi. Maybe I'm a little bit biased because octopuses are my favorite animal, but this is my channel, so I'm going to talk about them. From packaging warehouses to surgical rooms, traditional robotic arms have limits. They're rigid, they're clunky, they're prone to mishaps with delicate tasks. Once again, we find a muse in nature, octopuses, the ultimate multitaskers with limbs that put robots to shame. Octopus arms have no bones, only muscle, nerves, and astounding flexibility. They twist, curl, stretch, and squeeze effortlessly. They can untie knots, open child-proof bottles, and wrap around prey of any shape or size. Octopus have 500 million neurons, about the same as dogs, and 2/3 of them are in their arms, not their heads. Each arm literally has a mind of its own, capable of independent action without direct brain commands. Imagine your arms finishing cooking dinner while your brain takes a nap. You can only imagine how much there is to learn from and use in our technologies. In 2017, the Octobot was unveiled by Harvard, the world's first autonomous, entirely soft robot that can swim, crawl, and grab underwater, perfect for search and rescue missions, ocean cleanup, or archaeology, with an ability to be very flexible and squeeze through spaces that humans or current robots may not. Fast forward to 2020, Harvard Seas and Beihang University released their Tentacle Bot, a soft robotic arm tapered like an octopus limb with vacuum-activated suction cups. It can grip eggs without cracking them, iPhones without dropping them, or big exercise balls, all with just 2 valves controlling bending and grip.
Meet Spirobs. Researchers at the University of Science and Technology of China have developed a new kind of soft robot inspired by the natural flexibility of octopus arms and elephant trunks. Spirobs use their entire body to move and manipulate objects. Instead of just grabbing, they can bend, wrap, and adjust their shape to interact with objects more naturally.
Octopus-inspired robots are starting to make their way into real-world applications, from gripping easily bruised produce to assisting in surgical tool design to exploring hard-to-reach underwater environments. Their soft, adaptive design is reshaping how we think of machine movement and control. But what about the real things? Octopus themselves, intelligent, playful, problem-solving beings remain largely exploited. According to the Marine Stewardship Council, over 350,000 metric tons of octopuses are caught each year, totaling hundreds of millions of individual animals. That's on top of lab usage, fishing, and wild capture. This is despite their intelligence being nothing short of astonishing.
First thing that stood out is just how curious they are. For example, when you put anything into the tank, including your arm, they immediately swim towards it and just want to interact.
Octopuses can open jars from the inside and the outside. They use tools like coconut shells to build shelters, one of the only invertebrates observed doing something so complex. They have both short and long-term memory. They're also just incredibly cute and cuddly. Watch My Octopus Teacher on Netflix and you'll see exactly what I mean. Many countries acknowledge their sentience. The EU has restricted experimentation on them, and yet octopus farming is booming. Industrial facilities are emerging despite clear evidence that confinement severely stresses these animals. Again, we find that we replicate their genius, we borrow from their bodies while reducing their lives. This is another one of those things that I think about pretty often when it comes to climate change and the destruction that we've caused on the environment. Like, even if you take out animals from the equation, even if you take out the effects that we have on plants and wildlife, even just from a very selfish point of view, this destruction fucking sucks for humans. Think about the breadth of knowledge that we are losing every day with every new extinction. All of the things that we can learn from animal bodies and from plant bodies. Not to say that it's ethical too, because the way that we go about it is so wrong, but there's a library of knowledge that is being burned down day after day after day. You know, we borrow from nature, sometimes in beautiful ways, but rarely do we stop to ask if we actually respect it. The technologies I mentioned might seem clean and awe-inspiring on the surface, but behind every breakthrough is a trail of animal bodies. To reach these heights, animals are often dissected, prodded, and bred in labs, stripped completely of their autonomy. Even in the wild, the ones that we call inspirational are rarely free from our interference. Biomimicry dazzles, but dig deeper and the paradox is obvious. We admire the bodies of the same animals that we consume, we exploit, we destroy. Is this really how we want to thank our most generous and knowledgeable teachers? In part 3, we'll move away from mimicry and into utilization. Bioutilization, where we don't just copy animals, but we put them to work. We give them jobs that they never signed up for. It's the rawest, most literal side of our relationship with non-human animals, and it's next. Hope to see you there. All right, thank you so much for watching. If you found this helpful or if you'd like to support, a link to my Patreon is in the description below. I do have a little book club that I host every single month, which is really fun if you'd like to join. But also a like, a comment, a subscription goes a super long way in itself. So thank you either way. All right, see you next time. Abu Mason. Abu Mason.
Abu Mason.
It's literally Abu Mason. Abu Mason.